Okay, just a quick video to help with applied problem 3. So for part 1, I don't want to give away the answer directly, but let me come up with something really similar. If I have dy dx of -2 times some constant k times y, and then I'll make it a little different by saying times x here. This is separable. I want to get terms of y on the left, terms of x on the right. So to do that, I'll start by separating dy dx, -2ky x dx. But I got a variable in terms of y over here. K is a constant, so you don't have to move that around, right? I can divide both sides by y. So I got 1 over y dx equals -2k. Oh, sorry. This is dy. I copied that down wrong. Dy was in the numerator. So -2k x dx on the right. And then if I'm going to get rid of the calculus notation, the dy, the dx, then I just want to integrate both sides. So take an integral of the left, integral of the right. So the integral of y to the negative first, that's natural log y. That's what the left evaluates to be. And then plus some arbitrary constant c. And then on the right, the integral is going to be -k x squared, because the derivative of what I just wrote turns back into what we had, -2kx, and then there's that plus that arbitrary constant c. And then to finish getting y by itself, I want to raise both sides to the power of e, because e to the natural log of y is just y. So we get e -k x squared plus that arbitrary constant c. Or you could say that this is just y equals c times e to the -k x squared, where c is an arbitrary constant. So we use c for the concentration, so you might want to put a little c sub 1 in your problem, because your variable, this is a variable, not an arbitrary constant c. So just make sure to differentiate between that variable and that arbitrary constant. So for part 2, it's saying that we're giving these doses in discrete intervals. So discrete means we give it it's not constantly being given to this person. The medicine happens once every L hours, so maybe once every 8 hours they get a pill. Okay. So the concentration of one dose plus the concentration left over the previous dose is written right here. This is the dose. This is the pill you just took. We're assuming that immediately goes into your bloodstream, even though that's a great oversimplification of the problem, right? Our liver or blood system or however all that works, it doesn't immediately absorb it, but we're assuming the entire amount of the medicine's in your bloodstream as soon as you take it. Then plus whatever was left over after that previous dose. So this is L hours ago. So it's decreased at an exponential rate. And so this you'll see is it looks really similar to your solution in part 1. Okay. So for part 2, your goal is to create an expression for when the third dose happens. Here's the first dose. I'll start you off. Here's the second dose. And so what are you going to write for the third dose? It should look just like the second dose except a number in the exponent position. Because now we're 2 times L. Oh, it says it right here. We're 2L away. That pretty much gives it away. Okay, instead of writing L, you're writing 2L, and that will be your third dose. And so part 2 is just trying to get you to get the idea of what's happening with this series. We're adding one more each time. Okay, and so it's 1L, 2L, 3L. And so when you complete part 3, you're creating a series to represent the amount of medicine after the nth dose. So if I had a series that looked like this, this is not giving away your answer to part 2. Let's say it looked like this. Here, I'm just making, let's just do it like this. I'll just say, here's my series, plus 2 to the x, plus, let's do it like this, 2 times 2 to the 2x, plus 2 times 2 to the 3x. If this is my series, the pattern is pretty easy to see, right? We're summing from n equals 1, the first dose, to infinity, and it's always, every term has a 2, multiplying to a 2, and the x power is multiplying by 1. So we can say n minus 1 times x. Sorry, it's increasing by 1 each time. And so check out my series. If you were to plug in n equals 1, 1 minus 1 makes 0. 0 times x is 0. 2 to the 0 is 1. So that turns into the first term. If n equals 2, then we have our first term of 2, and then plus 2 times 2 to the x. Because if you plug in 2, 2 minus 1 makes 1. That's 2 times 2x. So this series is represented here. You're doing the same thing in part 3, except you're using what you created in part 2 to help you develop that series. Part 4, what values of k and l does the series converge? This might seem like a trick question, but if you look at it, it'll make sense. There's k and l both have to be values so that eventually this series converges and stops increasing. So you don't want to have a positive exponent. That's the big thing you want to look out for. Because if it's positive, that's a exponential growth. It's always increasing. If the exponent is negative, then you're always decreasing in these terms. Okay, so you want to make sure you pick a k and l so that the exponent is always negative. So you can explain that in words, or you could write it out mathematically. I'm okay either way. Okay, part 5 says the value of k depends on the potency of the drug. We got an initial dose of 4 milligrams per milliliter. It's given every 6 hours. So before we move on, because we're just going to get bored and miss out on what all this information is telling us. The initial dose, that was C sub 0. So we're told that's 4. It's given every 6 hours. That was what L represented, how often this medicine is being given. And it says the drug eventually reaches a concentration of 8 milligrams. That's not a variable in our series. That's what our series should equal. Okay. What is the value of K? Oh, and I think I pretty much give it away down here because I didn't want you to just sit there and think about what this blood equation looks like. This is pretty much the equation you want to work with. Okay, where A is a starting amount. I think I actually changed these numbers. So don't copy down what I'm about to do because your numbers are a little bit different. But it's a geometric series, right? Every time that we increase a new term, we're multiplying by the same thing. It's just there's a constant that we're always multiplying by. That constant is e to the negative k, negative lk every time. Yeah, because that would make minus 2 for the next term. That's how I was able to come up with this formula, because the sum of a geometric series is your starting amount divided by 1 minus the common ratio. So if the geometric series continues infinitely, that should equal the sum. And we were told that this blood concentration reaches 8 after an infinite amount of drug doses. Okay, obviously a person doesn't take a drug infinitely, but that's a way of safely deciding on a dosage and a frequency for the dosage, right? You consider what would happen if this person never stopped. So all you have to do is plug in the numbers. I'm given C sub 0, so the starting amount is 4. So in a geometric series, I spell it out right there. A is 4. L is 6 in my problem. I think it's different for your problem. We need to know what K is, so that's a variable we're trying to solve for, and it should all equal 8. So we just have some pre-calculus style algebra to do. The variable we want to solve for is in the denominator. So you got to multiply both sides of your equation by 1 minus e to the negative 6k to cancel out the denominator. So that cancels out. So you're left with 4 on the left side, and on the right side you're left with this. And then we can distribute that 8. We're still trying to get k by itself, so let's try to get this term by itself. We'll subtract 4 from both sides. Divide both sides by 8. And then to get k out of the exponent position, we learned in pre-calc that we need to take a logarithm of both sides. You could take natural log or common log, but natural log makes way more sense in this one because less work. Natural log of e cancels out. So that's what our right side equals, and this is what our left side equals. So to finish out solving for k, I just need my calculator. taking the natural log of 0.5 and then dividing it by -6. So for my problem, this is what k equals, 0.1155. For your problem, I think I spell it out in the PDF too. Same type of thing you're going to solve, just with different numbers. And that's it. So I hope that helps with the applied problem, but please message me if you have any questions.